Hey there guys, just thought I'd do a quick video showing you how to do these transcription translation problems. So a good way to get yourself familiar and comfortable with DNA, how it's structured and how it works, and in some ways how the body works with it, is to do problems like this where you might have a question that will give you an example of one strand of a DNA, a hypothetical DNA molecule. Super hypothetical because you will rarely find peptides this short in the human body. This is just something I made up on the fly. But if I were to give you such a hypothetical strand of DNA, like the one you're probably going to see in your quiz this weekend, I imagine if you're looking at this video now, or a future unit test, you need to be able to, one, find the complementary strand to this one, okay? Find the mRNA that corresponds to this particular strand of DNA, as well as the amino acid sequence that could result from this very hypothetical gene. So finding a template strand is relatively easy, or vice versa. If you're given the template strand, finding the coding strand should be relatively easy. We just need to find the complementary base pairs to whatever it is we were given, as you can see here. Okay. C binds with G, A binds with T, C binds with G, A binds with T, etc. And you also have to make sure you remember your DNA is anti-parallel, so the 5' end will match up to the 3' end. Okay, so if you're given the coding strand, the template strand is complementary to the coding strand, vice versa. These are mutual relationships between the two. And you could also be asked to find the mRNA strand given a strand of DNA. Most of the time you'll just be giving the coding, you will be given the coding strand of DNA. If you're not giving the coding strand, you know how to find it easily. Now, looking at the coding strand here and asking for the mRNA strand, there's only one difference. All the T's are changed to U's. Me's, you say? No, U's, as in uracil. T binds with U, so anywhere you see a T, you're just going to change that. Everything else remains identical. So, next thing you might be asked is, how do you translate a hypothetical gene in a sequence? And this is where it might get a little bit tricky. Not too tricky. First thing, remember that the 5' end of a 5' end of a gene corresponds to the amino group in a particular protein. So you start by putting the NH2 there, fast, and then you begin translating. But you have to remember one trick, and there's really only, I should say, two tricks to this particular question, and that is that you only start translation at the AUG, or if you're given a DNA strand, the ATG. Usually you'd go from mRNA to protein, just like cells do. So you would ignore this CAA, this CAG, and go right to the AUG, which is you already know is going to be a methionine, because all polypeptides start with AUG, which codes for a methionine. Moving on from AUG, what you have next, CCU. So if you go down to your codon table, this isn't the best codon table. Usually they have letters to help you zero in, but it's okay. We can make do with this one. CCU codes for proline. So the second amino acid in this chain is a proline. Next, we have UGG. Where do we see our UGG? UGG. Tryptophan. I like to say tryptophan is one of my favorite amino acids. It's just a weird thing to say. It's just like all the others. It has a ring. It looks big and impressive if you look up the structure of tryptophan. CUA is going to be leucine, and UAA is going to be, I don't want to spoil it for you, but I already know where it is. I'm just looking for it in the codon table. A stop codon. It's one of your 3 stop codons. Alright, so you don't necessarily need to put a stop there. You could just put the hydroxyl group that terminates all of your proteins. And this is something that will be asked of you in future assignments, as I've said, in more or less complexity than what I've shown you here. Take care.